The next topic in the Unit 3 for polynomials is writing equations. So the question is, or I guess the request is that we write the function rule that matches each graph. So remember, a function rule is just a function. So in Unit 1, transformations, we wrote equations, but they were transformations of our parent functions. So we had vertical dilations, horizontal dilations, vertical translations, horizontal translations, and then we also had some reflections. For a polynomial, the approach is going to be a little different. We are provided the x-intercepts, and then we are also provided the y-intercept. So we're going to use our understanding of roots and multiplicity. So we'll call this one f of x. I have an intercept at x equals -3, so I can write that as x plus 3. And then same thing at 2, we have an x-intercept at x equals 2, so I can write that as x minus 2. Next, we're going to look at the multiplicity. At 3, the graph passes straight through, so that means that factor will have a multiplicity of 1. But at x equals 2, the graph has a bounce, so that means it will have a multiplicity of 2. Next, we're going to utilize the y-intercept. So obviously this does not pass through the origin, so this means that there is some coefficient for this polynomial, and we'll call that coefficient a. Now we can use the y-intercept, substitute these values in order to isolate a and solve for what that coefficient is, because technically we have x and then f of x, or you can also write this as 0, f of 0. So f of 0 is going to be equal to -36 when we plug in x for 0. So I'll rewrite this so we can see the direct substitution. F of 0 is equal to a times 0 plus 3 times 0 minus 2 squared. So f of 0 is 36, so I'll plug in 36. And then we end up with 3 times -2 squared. And then from here, it's just algebraic manipulation to isolate a. So we get 36 is equal to 12a, which means a is going to be equal to 3. Okay, so this is -36. So negative, negative, negative. So a is equal to -3. And the reason why I stopped is because I noticed that this was going to negative infinity, so my coefficient should have been negative, because the leading coefficient in this function should be negative if we were to multiply all the factors out. So that's why I stopped for a second to see where that negative was. Okay, so that means our function rule will be f of x is equal to -3 x plus 3 times x minus 2 squared. And you have a calculator, you can check it, but you need to show your work solving for a and also the setup in the beginning. Okay. All right, the next one will be the same approach. We have a polynomial. We have 2 x-intercepts and then 1 y-intercept. We'll call this one g of x. And I can see that I have a y-intercept, so I'm going to use that to figure out what the coefficient is. So I'm going to leave a little bit of space in the front. So the first x-intercept is at -2, so I'm going to write a factor of x plus 2. My other x-intercept is at 5, so I'm going to do x minus 5. Now at -2, it is passing through, but it has that special slide in it, which means it'll have a multiplicity of 3. And then at 5, we're just going straight through, so that's a multiplicity of 1. And then I'll plug in my a here. So again, we have 0, g of 0, which is going to be plugged into the function so that we can solve for a. So be careful the tendency, especially in not lower math classes, but like when you're first learning how to substitute an input and then find the output, we tend to do things like this. G of x is equal, I'm just making up a function. G of x is equal to x squared plus 2x minus 3. And then say that you want to find the output for when x is equal to -1. This is not equivalent, all right? And especially in this course and future math courses, you will get docked for that because this is not a true equivalency. What you need to do is you need to restart. You need to rewrite it as g of -1 is equal to -1 squared, etc. Okay? So you don't want to set these equal because your input is x here, and then all of a sudden your input becomes -1. Okay, so be careful with how you do that. Just restart whenever you substitute something in, which is what I did up here. My input was x, and then now my input is 0, so that's why I rewrote the left side of this equation as g of 0. And I didn't just continue it from the first line. Now, if I wanted to, because my input is still 0, I can just continue from where I left off. But we need that -80, so I'm going to write that in. So we have -80, and then a, 2 cubed is going to be 8, -5. So we have -80 is equal to -40a, which means a is equal to 2. And I'm okay with this because this is an even function. The degree is going to be 4, and then both of the ends are going up, which means the leading coefficient should be positive. So we have g of x is equal to +2, x plus 2 cubed times x minus 5. And that's our function.